All right, guys, let's go ahead and begin our tech talk today on Siemens Solid Edge 2025, unleashing next-gen CAD functionality. Now, questions will be answered live at the end, but please go ahead and enter them into the chat as they come up if you prefer. Our presenter today is Aaron, who's located in our Cincinnati office. And a little bit about Aaron. He has over 20 years of experience in the design engineering field, including work in mechanical, environmental, architectural, and automotive industries. Aaron's design expertise has ranged from concept design to product development all the way through to production procurement. All right, Mr. Aaron, we are so happy you are here today. Welcome. The Tech Talk is now yours.
Hello, everyone, and welcome to another segment of our monthly Solid Edge Tech Talks, brought to you by your Siemens product experts here at Prolim. Your first time catching one of our live Tech Talks, we host the Siemens Product Solution Tech Talk every Thursday, including Solid Edge, NX, CAD and CAM, Team Center, Mindex, and SimCenter. So we know that you're all busy and likely can't attend all these Tech Talks that we have. So we're sure to publish these, all of our live Tech Talks on the Prolim YouTube page the same day, so that you can watch them on your own time if needed. So if you haven't already, go ahead and give us a follow on YouTube and get access to all this amazing free content when it's dropped. So here's a quick look at our agenda for today. So there are quite a few new topics here to be introduced or enhanced in the Solid Edge 2025 release. So we're going to run through what we felt were the most relevant to the average core CAD user to hit a bigger audience. So we also are going to show some enhancements to the Solid Edge Design Configurator portfolio product after the What's New 2025 core CAD topics are touched on. So this tool really simplifies the tasks of the task of designing different variations of very common products that you may build. And at the end of the presentation, we'll take any questions you may have. And if time allows, we can discuss what topics you guys would like to see for our next Solid Edge Tech Talk. So here's a look at some of the latest updates for release Solid Edge 2025 in respect to the core CAD functionality that we'll focus on here today. So just to name a few, we'll take a look at the synchronous pattern in ordered and in the assembly environment. We'll look at some new workflow improvements for the synchronous copy and paste command. We'll look at some improvements for the auto dimensioning aspects, some NX interoperability enhancements. There's a new active filter in the assembly environment, and some new additions to the new style palette that was introduced last release, as well as some great updates to the user interface. So that's a very common point that I think kind of gets missed a lot in some of these releases, but we'll touch on for you with a new update or to the new user interface that was introduced a few releases back. We kind of want to just touch on the continued development to make that even better for the users. So later, my counterpart, as I mentioned before, my counterpart Pratik will show some recent enhancements to the design configurator module inside of the Solid Edge 2025. And here's just a brief look at some of those topics that he'll be discussing. So with that being said, we'll go ahead and look at some of the enhancements made to the part modeling environment. So to start off, the new vertical command bar design plus synchronous UI makes the patterning much simpler and intuitive to create. So new users will grasp the command UI easily with this new quick pattern option. It does not require a profile or a sketch to be created. Solid Edge creates that profile for the user. Full ordered functionality on edit if needed, and then by sketch options for existing users that want to just stick to that legacy workflow or creating that sketch in place. And then finally, the last used option is now remembered for those users to quickly recall and for a more refined process. So let's go ahead and check out a quick little demonstration of this real quick. So here we have an ordered part that you can see here that's got a couple of protrusions and cutouts and whatnot. So if we just cycle over to the front view here and we just do a cross selection to select that entire feature, and we're going to just right from here, we're going to select the pattern command. And then in here, we're going to go ahead and select a circular command. And typically we would have to go and create a profile or a sketch, or at least create a sketch in order for us to be able to use this previously in the ordered environment. But now introducing some of that synchronous technology into the ordered environment, we can simply just select lock on a plane here and then select the center for this profile. There we go. And just like that, we can just add in a count. Let's say we'll go with eight patterns here, and we'll go ahead and just preview that and finish it up. And just like that, very quickly we're able to pattern that using some synchronous technology, but being in that ordered environment. So previously, if we wanted to do a pattern like that, we would have to navigate over into the synchronous environment and do that same operation, and then transition back into the ordered environment. So this is, again, saving us a few steps to do that. And again, because we are in ordered, we simply just select on that pattern that we created, do a dynamic edit, and then we can go back in and change anything, count. Let's say we needed 10 instead of 8. Just like that, super easy. So we're leveraging both of those synchronous and ordered styles in designing in one environment. So very helpful. So here we have another option here, or another scenario here, where we have a louver and designed in the ordered part here, ordered sheet metal part. And this time we're going to just select the louver from the Pathfinder, and we'll go into our pattern using our context toolbar. And we'll go from circular to rectangular. Let's change that back just for context here. And again, all I've got to do is just kind of highlight my plane, kind of fit it in there. And we'll do a X count of 3, Y count of Y. Let's change the spacing to 175 and 50. There we go, just like that. Finish the command. And very quickly, we're able to go in and create that pattern, that synchronous pattern inside the ordered environment. Again, this is saving us quite a few steps as we go through this process of introduction to some of the synchronous stuff in the ordered environment. And again, if we need to change that, we just do a dynamic edit and we change the count or maybe the spacing to, let's do 4. Space them out a little bit more, give us a little bit more room between the louvers. Just like that, we're able to create a pattern and then edit it very quickly here in the ordered environment. So Solid Edge now supports bin deductions and bin allowances and the bin length calculations from the bin table. So this is a great enhancement for those advanced sheet metal users out there. So these options are located in the Gauge Properties tab in the Material table. So we have new entries in the File Location tab in the Solid Edge Options. And there are also new variables in the variable table. So a new Excel table are included in the preferences folder in the installation location. So again, this is the bin deduction table.xls and the bin allowance table.xls. Similar to the gauge table.xls in format, but it'll return the bin deduction or bin allowance values. And again, we can edit those tables on command as well. So the bin calculation method can be set per feature, much like the neutral factor in the past. Sorry, per feature in the neutral factor in the past, which means individual features in a part model can now be calculated using the neutral factor, bin deduction, or bin allowance, providing the flexibility to the user design. And this is both supported in both ordered and the synchronous environments. Support for the bin table in the part and the draft file is also supported. The bin calculation methods used for each bin is listed along with its value itself. And then in draft, the calculation method command can be added to the bin table by the user. So again, this is just another variable inside of that. Inquire element is now supports bins as well. So we can use this inquire element tool to kind of look at these bin calculation methods that are being used with the bins only option selected. So it reports the bin calculation method and its value. So that's pretty helpful. And it has been overridden by the feature level. So you got some designations there to kind of identify how it was processed. Other properties are also listed, including Excel table and custom formula information if those are being used. And that inquire element now supports mesh bodies as well. So it shows the results from vertices, edges, and faces. So let's go ahead and look at a quick demo of this option. In this example, we've got a sheet metal part that actually is a multi-body sheet metal part. You can see we've got a main body, and then we've got a lofted transition body, each one of those having some different features. So let's go ahead and look at the material table, and just to kind of confirm what settings we're working with here. We've got a neutral factor as the bin calculation method by default, and then you can see that the standard formula for that neutral factor is 0.33. If we navigate to the flat pattern, we can see here that we've got some dimensions that are being derived from that 0.33 neutral factor. So let's bounce back to the design here. Now let's go ahead and change this global neutral factor. So we go back into our material table. We'll go ahead and just change the standard from 0.33 to 0.44. We'll go ahead and just apply that to the model. So now that has been applied globally. So we'll look at if we go to the Tools tab here, we have the bin table we can review. And this is kind of one of the new features here is that this calculation method kind of gives us the calculation method along with the value here, so we can kind of get an idea of what we're looking at. And again, because this is a global change, this has been applied to all of the bins in the part. And likewise, if we activate the lofted transitions flange, we can go here, or the lofted transition body, we can go to the bin table and see that that's same calculation method and value has kind of been applied across the board there. Now we'll transition back into their main body, and we'll activate our flat pattern, update and activate it. And we can see that we've got some changes based on that new neutral factor. We'll return back to the main body here. And we're going to go into this multi-edge flange number 1, and we'll do an edit definition. And under the options tab here, we have a couple of options here. But what we're going to do here is we're going to stop using the use default value for the neutral factor. And we're going to change this setting to bin deduction. And we're going to change this to 1.25. Go ahead and finish this up. So now if we hop over to the inspect tab, we can utilize our inquire element command, and we have this new bin only, drop down, and if we just select that multi-fledge number 1, we get all of kind of the element details in regards to that one bin. So again, we can see the bin calculation method is that bin deduction that we applied, and also what that deduction is that is in use, and that also it was locally overridden. So we see that new value of 1.25. So next we'll go ahead and make another change to another flange here. Let's find flange 7. We'll go ahead and do a edit definition. And again, we'll go into the options tab here, and this time we'll turn off again that use default values, and this time we're going to select that bin allowance. Then we'll go ahead and change this to 3.33 as the bin allowance value. Go ahead and finish her up. And then again, to kind of confirm our change here, we can go utilize our inquire element again, select our flange 7, and here we can see that information. Now if we go back into our bin table, we can kind of evaluate what we've done here. So if we scroll all the way to the right to look at the bin calculation, now we can see those bin deductions, those neutral factors that have been applied, and then that bin allowance that also has been modified and applied. So again, very easy, quick reference to kind of look and see what we've got going on in the model, and really showing the flexibility of allowing us to have different operational bin calculations for different parts of the design. So now let's modify, let's do one more scenario here, or option. We'll go back into our material table, and this time we're going to use, instead of the neutral factor, we're going to add in this bin deduction, and then we're going to use that new Excel file that we have access to for bin deduction table. Um, so we'll go ahead and apply this. And we're, first of all, we're going to go ahead and choose, let's see, let's select stainless steel. Let's go with a 20 gauge. So basically this is going to apply all of the values from the bin deduction table that have not already been locally modified. So let's go ahead and apply this to the model. Go back into our bin table here. And now we can see that all of the features that were established by neutral factor, by that other global, that previous initial neutral factor setting that we had applied, it's gone through and now pulled all of those values from that Excel table and modified all of the kind of the remaining features there. So we'll perform one more inspection here, and we'll go back into our inquire element. And again, with that bins only thing applied here, we can select on any of these bins. And here we can see that depending on the bin that we select, we can retrieve all of this vital information. So for instance, this bin was using this bin deduction table, so we can see that here. We can verify that it is in fact the correct bin deduction table that we're using, the gauge table, the sheet metal gauge. So a lot of flexibility and verification steps here using this inquire element and some of these other allowances for different features to be retrieved. Pretty helpful. And again, if at any time we need to maybe modify that table, we go back into our material table here. We've already got this use Excel file. We can just simply edit this sheet. This will pop up, and then we can make any changes to our file that we need here locally. So next we'll look at the etch support on bins and curved faces. So this is a pretty highly requested feature that's been added. So this supports etches on and across bins in the ordered environment. At this point, it's just the ordered environment. So hopefully in the near future, it will be supported in the synchronous environment as well. But for now, cylindrical and conical bin faces are supported, and then automatically places on all the faces that are touched by the wrapped input geometry. And then we can adjust the geometry correctly on the bin regions when the flat pattern is created. So, again, those etch commands options are also now remembered. So users' last settings in the etch command will now be remembered for the next command execution. And it applies to the selection filter and etch options. So let's go ahead and look at a quick example of this. Here we have just a simple sheet metal part. It already has a sketch embedded in it. So we'll go ahead and use this sketch here as an example for this process. So we'll go down the dimple drawdown and we'll go to the etch command. And then we'll go ahead and select, we'll change this from chain to sketch, and then we'll look at the options here, and maybe we'll change this to black and 1. And then we'll go ahead and select the sketch, hit accept, and then turn our sketch off, and then there you can see that that etch has been applied to the bend and the flat there, or on the flat piece and the bend as well. So again, to kind of mention here, so if we go back into the etch command, do an edit definition, and go back into the options, we can see that there's changed settings or options were remembered. So that's again another enhancement to 2025 for the etch command. So that's pretty helpful. The next topic is the etch in relation to the etch command is the new save to flat option. So we can now export that etch text as a text box, and it will honor any etches containing all of this text placed on the planar faces moving forward. Etches whose text layers fully or partially on non-planar faces will be translated as lines, arcs, and curves. So let's see a quick demo of this one. So here we've got another simple sheet metal part. Um, so basically, we're just going to go to the Save As command here, and we'll go to Save as Flat. And then this time we'll just select our top face here and then establish our x-axis. And from here, inside of our Options tab, we have this new Export Etch Text as a text box. So go ahead and just hit OK there. Save it. I've already created one. Say yes. And just like that, it's created. So another etch improvement was this wrap sketch improvement. Wrap sketch improvements focus on improving accuracy and reliability of results, basically enabling the creation of precise etches across bins. This improves the results curve connectivity across faces, edges, and guarantees that curves lay on parent surfaces so that they work as input of normal faces. Or, sorry, normal features. The wrapping around closed loop features has been improved as well. So let's go ahead and see a quick little demo of this. So here we have another synchronous part here. We've got another sketch here. We'll go ahead and activate that. We'll hop over into our surfacing tab here. And let's go under project. We'll go to the wrap the sketch command. And we'll select, make sure we're chained to go around the body. And then we'll do the entire sketch to be selected for the wrap. Go ahead and finish that. Hide our, there we go, just like that. We're able to wrap around the entire body. So there have been a couple of part and sheet metal quick enhancements for new round selection modes. So this new round selection mode makes it easier to get the intended result when using a fence to select a set of edges or vertices. So in the case below here, that's shown here, a fence was placed around half of the front of the part on the side view. So let's kind of look at how this plays out. Here we have another simple part. And basically, we're just going to kind of navigate around. Let's go to the Home tab, go to our Round command. And then we're going to select this edge to corner. We're going to just rotate to the side face, select that whole back side. You can kind of see that it's highlighting all of the edges and corners all in one swoop. So I'll just simply right-click, accept it. I'll undo it. And then we'll go and look at another addition here. So now just the edge command, and we'll kind of just compare the differences here. You can see here it's just highlighting the edges of the parts that are encompassed in that Windows Select. Likewise, one more time, we'll select the vertices. Same selection method. And again, you can see it's selecting all the lines that are encompassed in the connection there. So a couple of different options there that kind of should help and improve your selection process when creating some rounds. So with Solid Edge 2025 has made some improvements also to the copy and paste operations in the synchronous environment. So these enhancements will affect copy and paste, pattern, and mirror operations. So new algorithms will not require capping faces to be selected, so making operations more intuitive, simpler, and a little bit more reliable. So let's see what this looks like inside Solid Edge. So here we have a synchronous part with some gears across the face, but you can see it looks like we're missing one here. So we'll just go in, select our top view here, and we're just going to fence select that profile. And again, because we're in synchronous, we can leverage that great steering wheel here. Make sure I'm copying. Hit my torus, go ahead and rotate that around 22.5 degrees. And just like that, we're able to kind of create that copy and paste of an entire feature in there. Just super simple and super easy to do. Likewise, we'll do the same thing for this little cutout here. I think this is cutout 2. Nope, wrong cutout. Sorry. Cutout 1. There we go. So we'll go ahead and move our steering wheel over to the center of our part. Then this time, instead of going all the way up here to copy, I'm just going to hold in the control key on my keyboard and do the same operation, you can see I get access to copy that as well. Here, I'll just do -180. And now I've copy and pasted that feature over there. So you can see it's created another cutout. So pretty simple and easy to use command that's been introduced and kind of improving that continuous improvement of the synchronous technology. I've got one more example of the new copy and paste functionality. So looks like we've got some incomplete holes here. So I would just maybe want to do a copy and complete those other two holes, as well as maybe just grab this this angled flange here and copy that over. So I'll go to my top view here. I'm just going to go ahead and just quick select these two holes. And again, I can either hit the copy command here, go ahead and pull those over. Then I'm just going to use some existing geometry here to find my center point. There we go. Just like that, I was able to create a copy of those and paste those right into position. Then likewise, we'll go ahead and let's select this face, and we'll go ahead and select a couple multiple faces here. Move our command, or move our steering wheel up to the top. And again, we can either click copy here or just hold in control. I'll hold in control. Oh, I made a mistake. Let me go back. I actually want to rotate that. There we go. So go ahead and make this 180. And I didn't use my copy command. I forgot to hold in control there. Let me undo that. Let's try that one more time. All right, we got one face selected. We'll go ahead and hit spacebar to select a couple more faces here. Go. Move our steering wheel. And again, hold in your control key this time. Rotate that around to 180. There we go. And just like that, super simple, easy to use, copy and paste in a synchronous environment. So now let's go ahead and move over to some core enhancements to the assembly environment. So part and feature information has been added to the tooltips in the assembly sketch. So in order to try this out, we simply just enable show tooltips from the key points in the Solid Edge options menu. We can start a sketch, and in the assembly, observe how the cursor tooltips now have the part and feature information when the user hovers over the part edge, points, etc. And then step 4 would be the cursor tooltips is visible in the quick picks as well. So this can help differentiate between which parts the user uses and which parts are linked to. So active filtering in Pathfinder. So Solid Edge 2025 has also added the ability to filter Pathfinder and the graphic window in the assembly via the text search. So simply to try this out, you just toggle on the filter button in the Pathfinder, and then type your search into the Pathfinder, hit the search bar and hit enter, and there you have your results. And then step 3 of that, the Pathfinder and the graphic window should only display results matching your search text. So this filter state persists until the user toggles off the new filter button. There you go. Like that. There's also been some face style overrides enhancements in the assembly environment. So the ability to add or edit face styles in the assembly has been added to this release. So again, the steps to this process is to open up the assembly and navigate to the style palette. Choose which face option you want to select from the drop-down list, and then drag and drop that style from the style palette onto the face in the graphic window. So individual faces has been colored too, so we're able to do that. So the Style Picker also has some improvements. So a new command called Style Picker has been added to the style palette in Solid Edge 2025. Style Picker allows the user to sample style directly in the graphic window and then either apply it or save those sample styles. So again, to try this out, the workflow would be to navigate to the style palette and then click on the new Style Picker. Left mouse button click on a face in the graphic window to bring up the context menu with apply save to material, and save to current document all available. So when you click apply, this launches the part paint model with the sample style. Step 2, you save the material table, which saves the sampled style to the material table, and then save to current document, which would save the sampled style to the current document folder in the style palette. So synchronous patterning UI has been added to the patterning of assembly features as well. So the basic workflow for this would be to open up the assembly with an assembly feature in it, click pattern under the feature tab, and then now the new UI and the new option under the quick pattern in the vertical command bar. So this allows the user to create a rectangular or circular pattern without any additional sketch geometry. So again, like what we saw in the part environment, pretty much the same process for any feature assembly features that have been created. So let's go ahead and see a quick quick demo of this. So here we have a small assembly that's got a couple of components in it, as well as a hole created as an assembly feature. So if we move over to our features tab, we have this pattern assembly or pattern part, and we can just simply select what type of pattern that we want from here. We'll select a rectangular pattern, and we'll utilize this new pattern quick pattern, which enables us to just use elements on the part as opposed to creating or selecting from a sketch. So once we have our whole one selected, we'll move on to the next section, which is to go ahead and highlight our plane that we'd like. I'll go ahead and move part out of the way. I can't see it here, but we've got our boxes behind our window here. So we'll go ahead and change our X and Y counts from, let's make it 15, 2, and then we'll go ahead and change the distances between to 380 and 55. Go ahead and preview that, finish it. And just like that, we're able to create those pattern hole features that only live within this assembly. Again, they're not modifying that individual part itself. This just lives in the assembly as an assembly feature. So to take this one step further, we'll go ahead and also go ahead and pattern this stick from the assembly here. So from the Home tab, we'll just do a traditional pattern. We'll select a part that we want to pattern. We'll select a part that we want to pattern to. And then for the features, the pattern selection, we'll select the whole pattern. And then our reference position will be that very first hole. And just like that, we're able to utilize that new assembly feature of the pattern, and we can utilize that and use that in our traditional assembly patterning of parts and sub-assemblies. So pretty cool. So next we'll move on to the some core enhancements to the drawing PMI environments. So surface texture symbol updates have been enhanced. So enhancements for the GD&T standard compliance. So for the surface texture symbols, they've been updated as the ISO 29920-1, which was released in 2021. So now these symbols will be easily accessed from the drop-down to comply with the updated iOS standard. And then the other option, which is the aligned movable datum target support. So we now support the aligned movable datum target as per the ISO 5459. And these datum targets can also be added in drawings using the retrieve dimensions command and the drawing view wizard options. And then it also supported downstream in NX, STEP, JT, DWG, DXF, and 3D PDF is also provided. Location dimensions for the auto dimensioning and the 3D PMI envelope. Location dimensions can be added to virtual intersections of adjacent faces of outer fillets and center points of inner fillet. So again, being able to access finally in Solid Edge those virtual intersections is pretty powerful in my opinion. Parts can be dimensioned, WRT reference planes, which could be either base reference planes or manually created reference planes. And then these mutually perpendicular reference planes can be selected individually or in combination with model faces for auto dimensioning. Hybrid annotations have been enhanced as well. So this enables the placement of dimensions and feature control frames simultaneously. So available in the smart dimension and the distance between commands. The dimension lines can be connected to dimensions or feature control frames. And then the feature control frame saved settings can be accessed using that drop-down list. So the pulled out text is now supported as well for this hybrid annotation. So hybrid annotation displays will be adjusted according to the override set for the pulled out text. And then to piggyback off of the last slide, these dimension lines can also be connected to the dimensioned and or the feature control frame. Hybrid annotations can be exported as well for that downstream support to JT, STEP, NX, again utilizing that interoperability between the two. 3D PDF, DXF, and DWG. Some P&I enhancements in terms of the Solid Edge NX interoperability. These multi-frame feature control frames will be exported as true PMI. So both feature control frames will be identified individually in the MBD navigator and can be edited in NX for upstream or downstream processing. Sections created using the section by plane command will be exported to NX with editing capabilities as well. And then the section cap color defined in Solid Edge will also be now displayed in NX. Another PMI enhancement for the Solid Edge to NX interoperability is the auxiliary plane indicators will now be exported along with multi-frame feature control frames as well. In addition, sections created using Solid Edge profile-based section command will be exported to NX completely with editing capabilities as well. And then these will be transferred as box sections in NX. So next we'll move over to see some core enhancements to that always evolving user interface. So vector SVG icons. So for these, the icons are now used in Solid Edge ribbons, which can be scaled to different resolutions without any type of pixelation, which is pretty good. Which in turn kind of lowers the overall file size, as Solid Edge does not have to keep adding new icon sizes for future settings. And then for the docking pane, new modernized icons are used in the docking pane, which as per the new icon style, so it kind of just gives it that matching face from with the new interface commands introduced last year to this year. Solid Edge 2025 has reduced the size of part list properties and drawing view property dialogues to improve accessibility and availability for options. So as far as the parts list properties dialog, new uniqueness tab added by the group uniqueness option available on the options tab. And then for the drawing view properties dialog, options on the general tab kind of rearranged to reduce the height of the dialog for better visibility and lower possible desktop resolutions or bad eyes like myself. So for the dialog box search enhancements, so again, we introduced this in Solid Edge 2024 to allow us to kind of quickly, I've been in Solid Edge for a long time and I still find myself kind of struggling to find different tools and different options in this option dialog box. So with the addition of this new dialog search enhancement or search box in the options menu kind of really helps me out. But for the enhancements for this year, the search has been added for the following dialogues, which include the drawing view properties, the parts list properties, wiring table properties, tolerance table, blocks, FOP table, bin table, hole table, user table, and then finally that modified dimension style. So this search styles has also been added to the modify face style dialog box. So as we can see here, we can just simply search for a specific face or edge, and then it highlights the actual option or the color for us in the box. So another simple, at least simple from a user's perspective. I'm sure development is a little more complicated, but just a small nuance to help us find these features and commands and styles a little quicker and easier. And then as well for the material table, we can just search for a different type or a certain type of material, and we get a filter list for each one of those based on the return for the aluminum in this case. Recent document list also has a new search enhancement, so we can just search for recently used files real quickly, filter out all the other files, which helps us kind of navigate to those recently opened files pretty quickly. So we have a new redesigned vertical command bar for the extrude command, and I'll go through a few of these quickly. So the redesigning of the extrude command for below environments, so we have that in the part environment, both in ordered and synchronous, and as well as the assembly environment and the synchronous environment. So you can kind of see the three different environments here. So while reducing the VCB width, the static text will be removed and make space for the control. So again, we're kind of just slimlining the text as it gives just the commands. And then after reaching a specific width, the vertical command bar will not squeeze any further. So it'll basically get to the smallest possible size, as you can see for that minimum width over there on the right-hand side. Again, just giving us a little bit more display screen space. I know that was a pretty big feedback topic when with the new interface and moving from the horizontal to the vertical command bars. It takes up too much space on my screen. So Solid Edge is continuously developing and making this, refining this as we go. So the vertical command bar can now be minimized to allow more space in the graphic area, as I just mentioned. And again, I think this is huge in my opinion. So while minimized, performing a hover over action with the mouse will temporarily restore the VCB, allowing users to interact with it, move away, and the VCB will collapse back into its minimized state. And then the minimized VCB can be restored back to its default state by just using that restore option. So again, this is kind of allowing us to move this when we don't need it and pop it back in when we do need it. So again, there was another, the redesign of the vertical command bar for the revolve command as well. So again, kind of just showing you the three different environments, the ordered mode, the synchronous mode, and the assembly mode, and kind of what these look like. So it basically, the major changes for the VCB are the icons for important options. They're displayed sections using the section widget, and then all import options in VCB without opening other dialogue. So it's kind of streamlining our process to make sure we don't have to open and close other little options settings here and there. So with that all being said, I'll go ahead and hand things over to Pratik now to highlight some of the enhancements made in the Solid Edge Design Configurator portfolio product.
Thank you, Aaron, for all the nice updates in Solid Edge 2025. And now we will take a look at all the new enhancements that were made in Solid Edge Design Configurator. So first major update is we have something called as quick actions. And with these quick actions, your workflows have been improved by a lot. So what this quick actions is doing is basically creating the input fields as well as model actions for you so that you don't have to recreate that, and a lot of your manual work has now been eliminated. So let's take a look at this example here. Now here first what we'll do is we'll go ahead and open this bracket in a new part environment, and here I'm going to create or assign some discrete values for one of the variables here. So for this variable A, I'm going to assign some discrete values, that is 100, 110, and 120. Now, the way this quick action works for this specific model action, for this specific variable is that I can use those discrete values and create my input fields and model actions with just one single click. Now I'll go back to my assembly, and here to activate that quick action, you simply have to right click on the part on the main part, and you get this quick actions here, and then you get this whole list of options where you can add variables, add properties, add materials. If you have family of assemblies, you can add those individual members, and also export those individual part files or an entire assembly file into different file formats. Like, say for example, if you have a step file, and then you can export that as step file or an IGES file, Parasolid, and so on. So we are going to take a look at all of those options. For now, first we will take a look at the first one, that is add variables. So once I do that, I'll get this window from where I can select which variable I want to create an input field for. And once you click OK, it takes you to the second step where it automatically creates an input field for you and also assigns those discrete values so that you don't have to recreate that. And now this is your regular input field where you can, if you want to edit this, you can change the values from here, or if you want to create new values, you can create them from here, or also if you want to rearrange something, you can do that. So this is going to be your regular input field like you had, with the only option that this was created by the software for you, so your manual work has been gone. And now not only that, the next thing it also does is it creates a model action for the input field. So as you can see here, for this input field, I have a model action referencing that label A and creating an expression assigning it to input A value. And if you go to the last step, you can see that length A and all the different values it is using from the discrete list. So that was the first quick actions. The next one is where you can assign properties. So here it'll give you a list of all the properties that the software found that were created for that part, and from there I can add, let's say, comment. So this lets you add a comment here, which you can change at any given point of time. And then this comment here is going to be in a text type. The render style by default, it is smart enough to identify and assign that as text box. In the previous one, it was smart enough to identify that it was, so there were decimal values, and it gave it a drop down, assigning it unit length. And in the last option here, you can add the comment in the play step. And on the step number 4 here, you'll see that it creates a different model action here referencing the comments. So a lot of your manual work has now been automated. The next quick action here is to add materials. Again, like we have seen in the past, where you would actually go to the input field and start creating your materials one by one. So all of that manual work now is gone. So you can simply choose from the list. This is referencing back to your original Solid Edge material table, and assigning materials from there. Not only that, it creates a model action like we have seen for the first two quick actions, that is by variable and comments, the properties, and it is creating material for as a model action, assigning it back to that input material and the part name. So from this drop down, basically, you can select any material that you want to assign to your part. Now the next example is family of assemblies, right? So let's say, for example, here you had a family of assemblies, like which in this case I do, and it is using this shelf 75 as its member. So you can add the individual members to your input field as well. So it gives you this whole list from where you can pick and choose which member you want to add. It creates that input field, assigns the values, and in the last step, it creates two different drop-down options, that is shelf 65 member and shelf 75 member. And the last quick action is where you can export any given file into a different file format. So here I have this entire assembly, which I can export as any of these options here. I have a step file, JT, Parasolid. I can use any of these options here. It creates the input field, creates a label for you. It assigns the render style by default. And one more thing it also does here is it also creates a run condition, which means that it will only run if this box is checked. So this quick actions is going to be really helpful to automate a lot of your manual work that you're using with the current version of Design Configurator. Now let's take a look at some of the other enhancements made to Design Configurator. So next what we can take a look at is we have some new tags that have been added. So for example here for this input field A, what I can do is I can go to tags, and this is a list of tags, and some of the new tags added here include this no cache, which means that it will ignore the last used values when you're trying to create a new configuration, and it will start fresh. And if you want to force a value, in case since this is not if this was not a required field, then you can also force a value if the input field is left empty. So you can have the input field set to 120 and using this no cache as your tag. The other tag that has been added to the list is the measure tag. Now this is very interesting because it lets you measure the distances from your geometry, and it can use that as your value. So here I'll change my render style to text box. So if I go to my last step here, you see I get this measure a distance like a 2D measure option where I can select this option, and from here I can select the distance between two faces or edges. So I'll select this edge and this edge here, and you see it automatically enters that value as 40 because the current distance between the two edges here is 40. The next one is one more tag which lets you pick the model name. Now this is rarely used, but it sometimes can be helpful in case if you want to add a comment, or if you want to use the model name or a property or if you want to use a model name as a property, or if you want to send a message, you can add that in the form of comments. So for example, in this case here, what I've done is I can select the model. So the model is going to be this one. It brings up the model name because we have selected that tag, and we can add a comment here, like this part maybe was sent to the machine shop. Something like that. It's rarely used, but in such situations it is quite helpful. Then if you're trying to pre-select one of the input field values, right? So these tags are not only available for field, the entire input field, but also individual field values too. So here you can see you get access to these tags here. So in this tag we have this option for pre-select, which will pre-select this value when you're trying to create or when you're trying to play with the model in the play step here. One more thing we have is we have this option for selection here. So what this basically is doing is we can select this based upon different input fields. For example, here we would like to use 65 when my input B value is assigned as 50. And I would like to use this shelf 75 member when my input field B value is assigned to 60. So what happens here is, that looks good. So now what happens here is, if I scroll down, you'll see that if I change my input B length to 50, it automatically switches and selects 65. So you don't have to actually go and select that option. And if I choose this input B value as 60, it changes my shelf member to 75. So these are some of the other enhancements to Design Configurator.